Hey, good people, welcome back. This is Arthur Morris. In this video, we are going to begin our journey through partial fractions. All right, so the idea behind partial fraction decomposition is that uh, we can take a rational expression and decompose it into partial fractions. So um, our original rational expression is here, and we're going to do some work to get it decomposed to here. All right, so the partial fraction decomposition of a rational expression depends on the factors of your denominator. So we have four cases. The first case is when our denominator is a product of distinct linear factors. That means all of the factors in our denominator are different and they are all linear. That means we should not have any exponents higher than 1 on any of the factors in our denominator. So case 2 says that the denominator is a product of linear factors, some of which are repeated. So that means we may have x plus 1 times x plus 1 or x plus 2 squared in our denominator. But again, they're linear, so on the variable x, the exponent should be 1 on the variable of x. The denominator has prime quadratic factors, none of which is repeated. Okay, so prime quadratic factors means we cannot factor a quadratic expression, which means there's an x squared in our denominator. And none of the factors are repeated. In case 4, we have repeated prime quadratic factors. So we may have something like this one here where we have x squared plus 1 raised to the second power. That means it's there more than one time. It's repeated. Okay, so you may want to jot down that information there. All right, so the first type that we are going to look at, or the type that we're going to look at in this particular video, is the distinct linear factors in our denominator. Okay, so again, that means that the factors in our denominator are all different and they are all linear, which means we don't have any x squares in our denominator. Okay, and we will set this up in the form that's at the bottom of the page here, but that's a good example up top that we have where we have 9x squared minus 9x plus 6 equal or divided by 2x minus 1 times x plus 2 times x minus 2. And we will write the part that's on the right. And since we have three factors in our denominator, we will have three factors here: a over 2x minus 1, b over x plus 2, and c over x minus 2. And our job will be to take that equation that we created and find a, b, and c, and then write our decomposed partial fraction. So again, you may want to pause the video and jot these steps down. The first thing that we will do is set up the partial fraction decomposition with unknown constants a, b, c, d, whatever else we need in the numerator. And then step 2, we will multiply both sides of the equation that we created by the least common denominator. Step 3, we want to simplify the right hand side of the equation. Step 4, write both sides in descending powers, equate coefficients of like powers of x, and equate constant terms. So we'll end up with some new equations from that. It's a linear system, and then we will solve the linear system for whatever variables we have, a, b, c, d, and substitute those back into equation in step 1, the part that we created on the right hand side. Okay, so we want to write the partial fraction decomposition of this rational expression, which is x over x plus 4 times x plus 3. Okay, so the first thing that we want to do is to create an equation out of what we have. And you see we have two factors in our denominator. So I will have a over x plus 4 plus b over x plus 3. Okay, step 2, we want to multiply both sides by the least common denominator, which is x plus 4 times x plus 3. Alright, so on my left hand side, you see that the x plus 4 and the x plus 3 will cancel out with the factors in my denominator. So I'm left with x. On the right hand side, if I multiply x plus 4 times x plus 3, I have to use my distributive property, taking both of these factors and multiplying it times each fraction. So when I multiply those factors, x plus 4 times x plus 3 times the first fraction, the x plus 4 cancels, and I'm left with a times x plus 3, and then plus, when I multiply x plus 4 times x plus 3 times the second fraction, I'm left with b times x plus 4, because the x plus 3's would cancel. Alright, so from here we want to clear our parentheses by using our distributive property on the right hand side of the equal sign. Ax plus 3 times a plus b times x plus 4 times b. And then we want to kind of move our like terms right beside each other. When I say like terms, I'm looking at the terms, first of all, that just has the x variable. So ax plus bx. And then the terms that just has the regular capital letters. Now, out of this, we are going to create a system, a linear system of equations. So with this x, to make it match up, let's write it in full descending order. X to the first plus 0, since we don't have a constant there. Understood, 1x there. So I'm going to take the variables that have the x with them and match them up with the coefficient on the left hand side. So a plus b, I have ax plus bx, therefore a plus b equals 1 will be my first equation. And that's just matching that up with that. And then I'm going to match the regular constants, 3a plus 3b, up with the constant over here. So 3a plus 4b equals 0. Okay, so now here's my system that I need to solve and find the values of a and b. And once I find those values, I go back up to step 1 and replace a and b on the right hand side of the equal sign that I created up here. So I'm going to use elimination. I'm going to multiply the first equation by -3. And keep the second equation like it is. And that will allow me to eliminate the a variable. So -3 plus 4 is 1b. Then -3 plus 0 is -3. So b equals -3. But remember, I need a and b, so I'm going to use equation 1 to find the value of a. So equation 1, we had a plus b equals 1, and now we know that b is equal to -3, so I'm going to substitute. So So a minus 3 equals 1. Add 3 to both sides. Therefore, a equals 4. Now, those are the two values that I need. And now I can go back up here and write my decomposed partial fractions. So a is 4. So I'll have 4 over x plus 4. And b, the value of b, is negative 3. So instead of plus, I'm going to write minus 3 over x plus 3. And that's the answer. So again, you set up your equation, multiply both sides by the least common denominator, and then you work through it. So let's try another one. Okay, so on this one we have 3 over 3x squared plus 14x minus 5. Now the 3x squared plus 14x minus 5 can be factored. So let's use the room we had on the page before here, and let's go back and factor 3x squared plus 14x minus 5. So using the AC method, I come out to the side and multiply the first number times the last number. Then I find a pair of factors that multiplies to be negative 15, that adds up to be, gives me a sum of the middle number of 14. So I know I have to have a positive and a negative. So negative 1 and positive 15 multiplies to be negative 15 and gives me a sum of positive 14. So now I take these two numbers, come back over and rewrite my original expression, replacing 14x with negative 1x and 15x. So 3x squared plus 1x, or minus 1x, sorry, plus 15x minus 5. All right, factor out the GCF from each group. So I end up with 3x minus 1 times x plus 5. All right, so since my denominator, I can factor my denominator, we'll still use the same method that we used in the previous problem. Okay, so I have a over x, or 3x minus 1, equals or plus b over x plus 5. Okay, so I have my equation set up. I need to multiply both sides by the 3x minus 1 times the x plus 5. And we know that the 3x minus 1 times the x plus 5 is the same thing as the 3x squared plus the 14x minus 5. Therefore, on the right-hand side of my equal sign, I'm left with 3, because this would cancel with those. And then on the left-hand side, sorry about that, on the right-hand side, I need to use my distributive property, multiplying 3x minus 1 times x plus 5, multiplying both of those factors times each fraction. So when I multiply it times the first fraction, the 3x minus 1 would cancel. When I multiply it times the second fraction, the x plus 5 would cancel. So now I have the equation 3 equals a times x plus 5 plus b times 3x minus 1. And then we go through our steps. Distributive property to clear the parentheses. Okay, so we have a times x plus 5 times a plus 3 times b times x minus b, because we have b times -1. All right, let's get those like terms written in some groups here. So ax plus 3bx, because both of those terms has the variable x, and then plus 5a minus b, because they don't have the variable x at all. All right, now I did not have any x's on my left hand side, so to add in that missing term, I'm going to say 0x plus 3. So the ax plus 3bx matches up with the 0x, which means a plus 3b equals 0. Then the 5a minus b matches up with the constant over there. So 5 times a minus b equals 3. And now we have our system. So we can use the system to solve for a and b, and then take that and substitute back into our the part that we created at the beginning of the problem. This expression here. Okay, so really doesn't matter which one we eliminate. I'm going to go ahead and eliminate the b, since one is positive. I already have positive and negative. So equation 1, the least common multiple for 3 and 1 is 3. Equation 1, I'm going to leave it like it is. Equation 2, I'm going to multiply it by 3. So that will give me negative 3b to cancel with the positive 3b. So 3 times 5 is 15a minus 3b, and then 3 times 3, don't forget to multiply by the other side of the equal sign as well. It's 9. All right, combine those. We have 16a, the b's cancel, equals 9. Divide by 9, a equals 9/16. All right, we also need the value of b. So I'll use equation 1 again. So we have a plus 3b equals 0. We know the value of a is 9/16. Okay, solve the equation. Subtract 9/16 from both sides. And then multiply by the reciprocal of 3, which is 1/3. So 3 will go to 9 3 times. So we end up with negative 3/16. All right, that's all the information we need to be able to write our partial fraction decomposition. So now I go back up here, fill in a and b, and we're done. So a was 9/16. So I have 9 in my numerator, 16 in my denominator, times that 3x minus 1. And then b was negative 3/16. So I'm going to say minus 3 in my numerator, 16 in my denominator, times the x plus 5. And that's a wrap for this video. I hope you found it to be helpful, and I will see you on the next one. Thank you.